I meant to record fourth period. Got. There we go. All right, so number one, a ratio. A ratio compares the parts of something to each other. So I'm going to really quickly repeat what I did. So if I have 4, and these are itty bitty teeny tiny marbles now. If I have 5 blue marbles and 3 green marbles, I could say that is a ratio of 5 blue marbles to 3 green marbles. It's different from a fraction, because a fraction we would say I have 5 blue out of 8 total. So in a fraction, we're comparing an individual part to the total, as opposed to comparing the parts to each other. All right, there's the rule. So now on weighted averages. So again, this is just like you were figuring out the average of your quizzes and you only had 2 quizzes. If you had a 5 on one quiz and a 25 on another quiz, what's your average? Figure it out. You got a calculator. If you don't have a calculator, you don't want to grab one if there's one around you. So Sergey, there's one to your left. If you don't have one, raise your hand. I have one here. Oh, you got so lucky. Everybody else can walk. That's the one around you. Oh, you don't have one, do you? Should have been faster. I'm surprised you're not going to see. So if you have a quiz that's a 5 and a quiz that's a 25, what's your average? Use your calculator. Say it again. It's 15. That's the midpoint. I wish I would have been using that to do midpoint, because I took for granted that we all had that down, and a bunch of people missed that on the quiz. I'm going to show you what they did. But yeah, the midpoint is the average. It's the same as saying, oh, well, if I want the midpoint between those two, I want the average of those two. So you remember that, and hopefully some of you that made the mistake on the quiz, which there were only 3 questions on midpoint and only 3 questions on partitioning. So if you missed one of the 3, best you could do was a 70. And not many people got one of the other ones right on the midpoint. I haven't even gone over yet. I want you guys to figure that one out when I hand the quizzes back. So here's what a bunch of people did. They said, oh, I remember how we used to do this, where we'd subtract the 2, right? We did that. There was a lesson we did that, but it was partitioning, not midpoint. So a bunch of people subtract the 2. They did remember the divide by 2 part. Then they got 10. Well, they didn't get 10 because it was different numbers, but they got their answer. And they said, that's the midpoint. Ah, piece of cake. That one. And you should have known it was wrong. Because I always want you to think about your answer and think, does that answer make sense? That's not even close to the middle. What's the definition of a midpoint? So if I have the midpoint, if that was true, it better mean that this left segment is the same length as the right segment. And if you would have remembered that and thought about it for even half a second, you would have looked at the, because it was very obvious. I mean, it wasn't even difficult math. That left segment is 5, that right segment is 15. That's not even close. And it was the same way on the quiz. There was it made the left segment way shorter than the right segment. Just because I write a number in the middle of the line doesn't mean it's the midpoint. It depends on how long the segment is relative to how long that one is, using the numbers, using the endpoints and whatever number I thought was the midpoint. And clearly 10 is not the middle of 5 and 25. You actually didn't even have to use the formula for the midpoint. You could have just said, well, what number would make the left segment the same length as the right segment? So you could have just said, all right, well, let me try, well, 10 doesn't work. Let me try 15. So you could have written 15 in there. What is 15? Well, crap, right number. Didn't mean to guess the right number. Yeah. That works. 10 on the left, 10 on the right. That's all you had to show me to get credit. You didn't have to use any formulas for that one. For one of the midpoint. There was one easy midpoint and then one where you had to do it on a coordinate plane. But the easy one you could have just done just like that. Show me that the whatever the midpoint was, and then show me the left segment equaled the right segment. Why is this wrong? What did we forget to do if we do it this way? Okay. Thank you. I thought that was a raising of your hand. Well, we could have, but let's say we did this. I mean, there is a process that you can use doing this. What would we need to do with that 10? What is that 10? What's that 10 representing? It doesn't represent the midpoint, but it does represent something we could use. Yeah, it's the length of the two smaller. We took this number, which is the length of the big line segment, right? We said length is just subtraction. So this number is the length of the entire line segment. And then we said, okay, well, if we divide that exactly by 2, we're going to get 2 equal smaller line segments. So this is the length of the smaller line segments, 2 equal line segments of 10. But now if I know the length of the line segments are 10, what do I need to do with that number to get the midpoint? Because that's the length of the little line segments. What do I need to do? You know? What do we do? Randy, what do we do? Come on, big guess. What's that? No, you say multiply? What did you say? What do you think? Yeah. You could then say, well, if I know that so again, the left line segment is 10, the right line segment is 10, you could say, if I know the left line segment is going to be 10, I can start, add 10 to that, and that will get me to. Again, there were 3 different ways to do it. The third way is the actual midpoint formula, which is just like finding the average. The midpoint is the average number. So if I have an endpoint of 5 and an endpoint of 25, I find the average of those, add them together, average of that is 15. I didn't care which way you did it. I gave credit for all 3, but unfortunately, some people did this, got 10 and just wrote 10 in the middle, or well, it wasn't a 10, whatever the number was. And that was not correct. That is not the midpoint. So make sure you check your answers. That's the moral of that story, especially when it's something that should be a fairly simple concept like midpoint. You should be able to check it and know, oh, wait a minute, that doesn't make sense because my left little line segment is way smaller than my right line segment, so that can't be the midpoint. And then from there, hopefully you can figure out what the correct midpoint is. All right. Now, back to weighted average. How did we say? I'm going to skip 2. We're just going to go into weighted averages. We already said the heavier it is, the more it pulls it in that direction. How did we actually do the formula? What did I tell you to do with the weights and figuring out the X value and all that? You can write it in a whole separate area of the paper or of the problem, W1, X1, W2, X2, but what did I tell you to do? I thought it was cleaner, but some people did mess the other way up. Some people mess this way up too, I guess. I just keep them together. Like if point A has, in this case, a weight of 2, then put the weight with point A. What's the X value for point A? Where do the weights come from? The weights come from the word problem. If you don't automatically remember that, don't ever try to get the weights from the number line. That's the X values. The weights come from whatever it tells you in the problem. And if it doesn't tell you the weight of one of them, what's the weight? 1. And then just make sure that it makes sense that the weight is like 2 times or 3 times the other weight. All right, so once we label that, if you sort of kind of remember the formula, it's kind of hard to make a mistake and put anything in the wrong spot. We just said, all right, well, the formula says to multiply the weight times the X of 2 times 5. Go ahead and try to do it now that I've done that. I'll give you another minute if you didn't get this far. not going to give a super long time because you got a lot to do, but some of you, I think now that you kind of refresh your memory, I think now you can probably do it when maybe you couldn't do it for homework. I gave you already the first part of it, so you just have to finish. What goes on the bottom, we said? So we can either say weight 1 plus weight 2 if we're using the formula, or we could just say add all the weights up. Some people, and this was probably the biggest mistake on the weighted averages quiz, some people added the x values on the bottom instead of the weights on the bottom. Remember, the denominator, the bottom part of the equation, the fraction, is the weights. Add the weights together for the bottom part. So now you should definitely know. Equal, I'll give the few minutes, not minutes, seconds. Yeah, use your calculator. Don't, I mean, you can do it in your head, but have a calculator and use your calculator. All right, what else do I write? I had the 2 times 5. I did that part for you. What's next? Yeah, we're going to add all of the weights times the x's, basically. So if I would have had another point, I would just have 3 things on top. So now I say 3 times the 25. Again, if you've written the weights in the x's with the point, kind of hard to put them in the wrong spot. Unless you put them on the bottom, I guess. The x values on the bottom. Then we add up all the weights on the bottom. And you should have gotten 10 plus 75 over 5, which reduces down to 17 is what your final answer should have been. And that is the point here. We don't have to add that to anything. That formula does calculate out exactly where the point is on the line. And it makes sense because B is heavier. So we know the midpoint was 15. So if B is heavier, it did pull the average. It pulled the midpoint more toward B. And it wasn't way heavier. It's only 3 to 2. So that makes sense that it should be somewhere around that area. Any questions on that? Again, most of the grades were pretty good on weighted averages. There are some people that'll be doing a retake on it. So hopefully that review will help you a little bit. Good. All right. We'll see. So I'm going to teach you a trick. I don't like teaching tricks. I like concepts because if the district switches something around from, you do realize like the teachers have no idea what's on like the district tests and the end of course exam. I've never seen them. We're not actually even allowed to look at them. So what we teach you in class is not necessarily the way the district or the state is going to ask those questions. That's why I'm not big on memorizing steps, unless we just have to. I want you to understand it so that you can kind of figure it out if they give you something a little different. I'm giving you something here that's just steps and just kind of a cheat sheet. If we have a problem that deals with weights, then you guys are, at least based on the quizzes, you guys are pretty good at that method. There's a way to take a problem that has a ratio. So now we're partitioning that line in a ratio of 3 to 2. There's a way to actually do that just like it was a weights problem. And there's only one little teeny adjustment you have to make. And then you just do it just like it's a problem with weighted averages. If I want to find the point on the line with a ratio of 3 to 2, first of all, what does that 3 to 2 mean? What do I know about the point that I'm going to put on there? There's something I should know. Correct. This represents the length of the left. And this represents the length of the right relative to each other. So if the 3 is bigger, or if the left side has the bigger number, then the left side is going to be the longer segment. So immediately I should know the points going to make the left segment a little longer than the right segment. Which, when it comes to weights, it's the opposite, right? Because if this is weighted more, it would actually pull it this way, which would make the left side smaller. So which one is the heavier point then? A or B? Again, not ignore that. That was the bell work problem. So which one is the heavier point? If the left side's going to be longer and the right side's going to be shorter, which point is heavier? Even though I didn't give you weights, I gave you lengths. So I gave you a ratio, right? But that tells you that the point is going to be, so if the midpoint is still 15, so that's still the midpoint, is the point that we're trying to put on there, point P, is it going to be to the right of that or to the left of that? Based on the ratio. The left side is going to be the 3, the right side is the 2. So we need which segment to be bigger? Yeah, we need the left segment to be bigger, right? Because it's telling you here, the length of the left is bigger than the length of the right. This is 3, that's 2. So if the left segment has to be bigger, our point, again, has to be to the right of that. So it's the same concept as the weights. It's just sort of opposite. Because now this is telling me that the bigger segment has to be here, which actually pushes the point farther away, as opposed to the weight, which pulls it. Hopefully you understand that. If not, I'm just going to give you what you need to do. If you have a ratio problem, and you want to do that using weighted averages, so everybody seems pretty good with that weighted averages thing. All you have to do is this. The first point, so I'll still write letters. So if A is your first point and B is your second point, the only thing you have to do to make this into a weighted average problem is you flip those numbers when you do the weights. So instead of the first number being the weight for the first point, it's the opposite. A gets the weight for the second number. B gets the weight for the first number. Once you do that, it's the exact same problem. And it literally is the same problem we just did. So I'm not going to make you solve that one out. I'm going to give you another one. Now you see this is the same problem we just had, where A has a weight of 2, B has a weight of 3. We would get a point that was on 17, which would make the left segment longer, which it should be, and the right segment shorter. So all you have to do a weighted average problem from a ratio problem is just flip the ratio. Make the second number the weight for the first point. Make the first number the weight for the second point. All right? We're going to practice. So those of you that are nodding, well, nobody's really nodding, but that aren't saying anything, but yet you still don't understand it, we're going to practice a couple of them. But any questions before I give you one to practice? I mean, last class, almost everybody got it from there, so hopefully we're all getting it. All right. I'll grab it. You guys work on this. -3, 16. Partition it in 3 to 1. Got it. Yes, ma'am. Email, is it today? Doesn't have to wander around. You guys work on that. It'll take you a couple of minutes. Let's walk down. This is the only other room. And here, you know, all right. You need to, yeah, you can come back here if we haven't gotten your word yet, but maybe I'll try it. What room are you in? E5, okay, all right. All right, so, again, the only thing, and I hate memorizing stuff, but it'll certainly, for the retake, it should certainly get you a better grade on the retake, because, like I said, most people did really well on the weighted averages quiz, and that will just change this into a weighted averages quiz. If I have an A and a B, again, the letters don't matter. Just make sure you flip the order of that, and the first number is going to go with the second point, second number with the first. So what would the weight of A be? What would the weight of A be? I'm going to call in somebody. Ricardo. What would the weight of A be if I'm going to do this using weighted averages instead of trying to do the whole 4-step partitioning thing? Think about it like the tour. An email about that. What do you think? Say 7? Well, I just want the weight for now. Just what would the weight be? We're going to do the weights of both of them. So what would the weight for A be if that was the way I wanted to try to do this? Like I wanted, instead of doing the whole, because normally we would make this into a fraction. We'd figure out the length of the line, which would be 19. We'd multiply those and we have to add back into the first number. Well, that's the X value. So let's call on, all right, Kai, you haven't said anything. So the weight of A would be 1. The second number in the ratio becomes the first weight. And so if you didn't get that part, I'll give you another one in a second. We'll go faster through that one. So therefore, what's the weight for B then? Voldemort. So if we use the second number in the ratio to be the weight for, ignore all of this stuff. So I want to change this into a weighted average problem. So I just take the ratio and I say, well, the second number is actually the first weight. So what do I do now? It's the weight for B. Great, it's the first number. So the first number becomes the second weight. And by second, I just mean the point that's to the right. Now it's just a weighted average problem. If you didn't already have that, I'll give you a few. I saw a bunch of people write that down. I'll give you a minute to try to do that now while I send an email, and then we'll solve it out super fast. Let me send the email first, Sergey. Were you just asking for me to check? Let me send this real quick. What about you? What did you need? Who's that, Alexa? I knew somebody was one. Yeah. Trade your phone out, please. Right there. You can just trade it and put it up there. While I'm sending an email. Oh, I can't send an email. I'm recording. Shoot. Bye. All right, so first piece, Stefan, what do I do?
Add the weight with the x value.
So what's the x value? Okay. So I would say 1 times -3. Don't forget the negative. Some people in the first class forgot that negative at some point, including me. What about actually, Yasmin? I know you weren't here, but I'm still going to ask you, what do I do next? What would the x value be for that second point? The weight is 2. Like, what's the weight or what's the x value for that? Yeah, it's just whatever the number is, exactly. The x value comes from the number line. The weights come from the problem, or in this case, from the ratio itself, if you're changing a ratio problem to weights. So I multiply those together, 2 times 16. What goes on the bottom of it? Raina, I haven't asked you anything yet. Yeah, the weights are always the bottom. We add the weights for the bottom. You can say W1, W2, whatever. I just know I need to add the weights. Doesn't matter what order they're in. Wait, why did I have a 3? I mean a 2. Nobody wanted to correct that? Somebody, I did hear somebody say 3 actually at some point. I don't remember what it was. So yeah, I need to correct that here. And then I need to add it here. There, that's better. So negative, then when you do this, if you use a calculator, just be careful. So you should have gotten 45 divided by 4, or what is that, 11.25? So if you got 11.25, that's the partitioning quiz right there. It's just now when you get the ratio, you're going to flip it around. So you'll take the second part of the ratio. Now, if there's more than 2 points, oh wait, no, we didn't have more than 2 points in partitioning. That was only weighted average. So yeah, you'll never have to worry about that. Just take the second number in the ratio and make that the weight of the first point. Take the first number and make it the weight of the second point, and then just do it using the weighted average formula. Multiply them all together, add in between, divide by all the weights added together. So I think that'll clean up a lot of the partitioning retakes. I'm going to try to give you a freebie on that because so many people struggled with that. And now we have a new method, even though again, this is, I hate kind of cheat sheet methods, but it works. Works pretty well actually. Any questions on that? I'll have the sheets ready on Thursday for you, what you need to do to be able to take a retake. And I'll tell you at that point if I'm going to give you a freebie at some point on the partitioning one, and then you'll know if you just need to do a retake for other ones that you need to. So you'll get more information on that on Thursday. Any other questions? All right, so now we get to some pretty boring stuff, unfortunately, but we got to do it. It's a bunch of vocabulary, and I've told you in geometry, that first lesson a lot of times is gonna be a bunch of vocabulary. I didn't, oh shoot. I tell you what, we're gonna do it differently in here. I want you to grab books. We're gonna go ahead, we're a little ahead of where the other classes were here. We're gonna tear the pages out of the books, and then once you've torn them out, put them over here so that the next classes don't use the same ones you've already torn the pages out. I'll tell you what pages right now, so if you want to go ahead and get started, maybe I'll move, let me grab a back and I'll move some of it closer to everybody. All right, so those of you that are closer, can go ahead and do that. If you're in the back of the line, you can come over here and grab one of this stack. Sure. And the pages you need, we're now starting module 2. So we're done with module 1. That was all line segment stuff. Now we're getting into angles. So page. All right, so start at page 57. I got it. Start at page 57. Oh, so grab a book. Actually, there's some right here still. So grab a book. We're going to go ahead and tear a page of that. I didn't do this with the other class, but. I think we're just going to go from. Yeah, let's just go to 90. So from 57 to 90. Pages 57 and 90. We're going to use the rest of those in that module, but we'll tear them. We can do that probably Monday, right? 5 minutes in that kind of stuff. That'll get us through whatever you think. Don't worry about stapling today unless you're done like super fast or something. Oh yeah, as far as my, I'm gonna do a clearing out record real quick. So I'll go over that. You can tear them out multiple pages at a time. Be careful. You need to like make sure that don't tear them out like that. You got to have like a little, whatever that would be called, on page or something. Get it started, which some of you do that. If you're done, you know, the page is empty. Yeah. Did you carry it out yet? No. So let's go to the online book. And it's going to be a bunch of definitions, but at least you guys already have the stuff torn out, so you won't have as much to write. Oh, I don't want that. Having issues with the online book earlier, so hopefully it works. Yeah, looks like we should be good. Should still be the same place where we left off. Oh, we're not. Remember, all this stuff is available to you. So if you're behind some retakes, eventually I'm going to, oh yeah, I forgot to mention that in the other class. I'll mention it now. So I think what we're going to do on Monday, raise your hand if you do not have a district laptop. Raise it high, I need to see it. 7, 6, 7. If you have one, bring it. All right, so bring your laptops on Monday, because what I'm going to do is you're going to have to do these example problems before I even let you do the quiz. And you have to achieve a certain grade on it. If you don't ever get that grade, you won't take that quiz. So to even take the quiz, you're going to have to kind of like pass a pretest sort of. And you have to get like a passing grade, like a 70 or 80%. See, the other some are doing 80. I might only do 70. So I have to talk to them and see how it went when they did 80%. But yeah, I'm grading way too many retakes. All right, so we are moving into angles, and you can write angles and congruence as your topic. Angles and congruence, which is a whole bunch of stuff. So that's just the topic for the whole entire module. We only tore out the first 3 lessons for the module. But there's a bunch of definitions getting started. Some of them you're going to know, some of them you won't. The first one you need to know is what array is. Again, if I don't grade notebooks, you need to be able to, now, if you don't do well on a quiz, I'm going to say, show me your notebook, show me your notes. And if you just have a bunch of blank pages with nothing written on them, then you're going to be filling in those pages. But still maybe be writing stuff down just in case you don't do well on a quiz. Then you don't have to go back and do that step for the retake process. But array is basically, it's kind of like a line segment and a line mixed together. A line segment had 2 endpoints. A line didn't have any endpoints, right? It went on forever in both directions. Array is kind of a mixture of those. It has 1 endpoint, and then in the other direction, it goes on forever. So I could say, and the way you name it is you can use, it's always the starting endpoint is always first. But then from there, I can choose the B or the C to name it. So that array that you're looking at visually right here, I could call that this array right here for those people that are watching the video. They can't see me pointing. That array I could either call array AB or array AC. I could use either the B or the C as the second part of that. I do need that symbol above it, the arrow with only, or the line with only 1 arrow on the right, showing that it keeps going. Even if it goes in the, boy, I'll be honest, I'm not sure about this. I'm going to say it anyway, like I am sure about it, but I'm not sure about it. Even if it's going to the left, I still put the arrow, like the little arrow part on the right. So like if C would have been the end point, but it was going that way forever, I'd still put this little guy on the right side of that. That's just the symbol. To the right. Doesn't matter which way the ray itself is pointing. I would never take off if you put it pointing in the wrong direction. So don't worry about that. I'm not even sure if that's going to be something on the district tests and the POCs. As long as you understand the difference between array is 1 end has an endpoint, 1 end goes forever, as opposed to a line, which goes on forever both directions, or a line segment, which has 2 endpoints. And then as far as naming it, we always start with the endpoint that is technically the start point. And then the second letter is the direction that the line is going. And we can pick any letter. So this down here, if I wanted to name this array right here, I got all kinds of options available. I have to start with D, but I could say DA, DB, DC, any one of those 3. Pick any other point on that line going to the right, on that array. Now, what they're really telling you here has nothing to do with that. They're telling you in that figure, if you'll notice, that kind of just looks like a line. That's the same thing we studied for a line. It goes on forever in both directions. But if you have these points on a line, technically you have rays in that line as well. I could say I have a ray that starts at point A. I could say this is a ray starting from point A and going to the right. It'd be ray AB or ray AC, kind of like up above. I could also say there's another ray in that starts at point B. I use blue. I could say that's ray BA or ray BD. Oh, and you can't change the order. Like I can't call this ray up here. I can't call this ray CA or BA. You've got to use the correct point first, which would be the endpoint. A always has to be the endpoint. That's why down here in the blue line, I can call that blue ray I can call that BA or BD because I'm starting with the B and going the other direction. I'm not going to spend as much time on naming stuff in this lesson as we did because there's so much stuff in it. Here's your first big concept. If I have two rays, and again, a ray goes on forever, so pretend like I'm holding the endpoints. So these points right here, like what would be the endpoint of the ray. So it goes on forever that way, it goes on forever that way, holding the endpoints. If I take these 2 points that I'm holding, those are endpoints, they're single individual points, and if I put them right on top of each other, now technically it's really just one point. Don't really ever have one point on top of a point. That forms an angle. So that's what a definition of an angle is. It's 2 rays, and I just made it a common endpoint. Again, you write as much as you want to write. If you want to write notes around this, that's up to you. There are a few things where I'll say you need to know this. That's what I'm writing. So an angle is actually formed by 2 rays. This point right here where they overlap, you need to know that's the vertex, which I'm skipping, I guess, around a little. Yeah, vertex, then they're the bottom. That's how you spell it. So the point that they have in common, basically, the point they share, or you want to go back to whenever you first learned all this stuff, the corner. Vertex is the corner. But it's the point they have in common. It's really what the vertex is. Now, so now I'm going back up to this one again. We kind of skipped down a little bit. If I take these 2 rays and if I open them, and if I basically make them going in the exact opposite direction. So now one is going out to the left, one is going out to the right. They still share that one point, but they are going in the exact opposite directions. How many degrees is that? 180 degrees. So you need to understand it's basically a straight line is 180 degrees, but the way that you're forming it is you're taking 2 rays and opening it up into a straight line. But you need to understand a straight line is 180 degrees. That's a huge concept in geometry. As far as naming rays, there's a bunch of different ways. I'm sorry, naming angles. I do need to go over this real quick. So that little symbol means angle. That's the first thing. We can just name it after the vertex. So I'm naming this one over here, by the way. Angle A is all I need to write. Or I can pick any 3 letters that are basically on those 2 rays, as long as one's on the left ray, one's on the right ray. I can't say BAC or CAB or anything like that. And the key is you'll notice the middle letter has got to be the vertex. You've got to put the vertex in the middle. So all they did is they say I could name it DAB, DAC, BAD, CAD. Doesn't matter which side I start on. The main thing is just that middle letter is the vertex. And you'll just, I mean, I'll do some of this just as we go through. I'll name different angles and you'll see that. So I'm not going to spend a bunch of time on it. Let's see. So we did all of that. Boy, there was something I did in the other classes. What was it? I'm not going to go. I went over naming a lot more in those classes, and we ran out of time super fast. Remember, I'll be honest, I don't remember what else I said. So this side of the ray, I'm sorry, this side of the angle, we're just using the name of the ray. I don't think that's a big deal. I don't know when that's ever going to come in play, but they just said this side is ray AB or ray AC. They could have also used. This side is ray AD. So I guess if you're describing an angle, maybe you might say side AD or something like that. I don't know. I don't recall ever having used really the sides of an angle before, just mainly the name of the angle itself. All right. Any questions on any of that? Yeah. I think that's, yeah. All right, so here we go. When an angle is formed, something that a lot of times we don't really ever learn or think about. I'll be honest, it's not something I really, the first time I taught geometry, I didn't teach it in a lot of detail. Technically, there are two angles formed by these two rays. One is the angle that we think of as the angle that they formed, this little guy here, but technically, this is an angle also on the outside of it. So if you'll notice, they've colored this part in blue. That's the interior angle. So, oh, here it is right here. So that's the interior angle. It doesn't say this, but I would think this is true. Like every interior angle is going to be less than 180 degrees. Because it's going to, if once we get to a straight line, if we then keep going, that would make this side down here the interior angle. It would flip. You don't need to write that down. If that changes, I'll let you know. You need to understand there are two angles formed. Interior and why it's doing this, it never does this. Interior and exterior. What would the sum of the interior and exterior angle be? So here is an exterior angle there. There's an interior angle. I added the measure of those two angles. Like if I could measure those angles and I add together the two measures, what would they equal? What? We got it. Or two, actually two. What would, so again, I measure this angle here. Oh, how do we measure an angle? What's the tool? Like, what's the tool that's used? Do you remember the name of it? No, it's a protractor. Yes, correct. So I'm going to go over how to do that. But if I took my protractor and measured it, so I had this angle here, that angle there, and I measured those, what would those two add up to be every time? The interior angle plus the exterior will always be the same. 360. They form a circle. I take these, and I'm sure it's not perfect with the way I drew it, but if I took this and I slid it up, that's a circle. Because between the two angles, they basically cover the whole distance that the angle could possibly open up to. They're always going to add up to be 360, an interior and an exterior angle. Oh, it's actually saying the points lie, and I didn't even go over this in the last class. They're saying the points lie. Oh, that was cool. What I did there? Somehow I zoomed in. I know, I didn't even touch it. Well, no, I know I can do that, but I didn't. I mean, weird. Oh, I did it again. Getting off track. Oh, now it just. Oh, maybe that's something. Now that it's highlighted once I text it. There, so anyway, I like that. I just want to be able to use it in the future instead of zooming in and zooming out. I wonder if that changes the writing. So let's see. I'm not going to do long descriptions on anything. Oh, we do need to do this for sure. So let me zoom in because this is. So there's another way to name angles. Sometimes they're just going to write a number in the angle. So instead of using the letters, they may just say angle 8, angle 1, angle 2. So they'd still use the little angle symbol, but they may say angle 1. Or they may say angle 8. So they might write a number, and actually a lot of times you will see a number in there or number. Now, this number has nothing to do with the measure of the angles. I didn't go to that. They're just naming the angle 8. They're not saying that is a measure of 8. So make sure you understand that too. If they're going to say, if they're saying the measure of it, they'll put a little degree symbol there. That's how we measure angles in degrees. If you don't see a degree symbol there, and again, I'm not saying that sometimes they won't accidentally forget the degree symbol. Theoretically, it should be there, but if you see a bunch of numbers like that, clearly that can't be the measures of those angles. They're just going in order, 1, 2, 3, 4. So it wouldn't be degrees, they're just naming the angles. So what's another way to name angle 10? I'm going to go to Ian. I haven't called on you at all. What's another way to name angle 10? So this is one where I will mention, we can't just name angle 10 by one letter because there's too many angles coming off of that vertex. There's a whole bunch of angles. Like using this one single vertex, I got a bunch of angles. 1, 2, 3, 4, 5 angles all coming from that vertex. So I can't name it using one letter. Got to use 3 letters. Fun. Well, I didn't do that. We will talk about that real quick. Ian, take a guess. How many letters do we need?
You only need 3. I
3.
guess.
And the vertex just has to be in the middle. So what points are on? What's that?
HDC.
So H. So again, I said 10. So if you're having trouble seeing what 10 is, 10 is this one. So now I just need to pick 2 points that are, D is going to be the middle because D is the vertex. So now I just need to pick 1 point from one ray and 1 point from the other ray. So I don't even know which ones you said, but if this wasn't what you said, you can tell me what you said. But H, D, C, or C, D, H. Order doesn't matter which way. So that's the way you would name that in addition to just saying angle 10. I'm not going to spend more time on naming it because we'll go over that as we do other stuff. We do need to talk about some very important definitions. One of those being this. When 2 lines cross, so if they form an X, and they have to be dead straight, like this line is a straight line, this line is a straight line. This here is not, like I can't say these 2 lines are crossing somehow here. Yeah, this is a straight line, but this is not one line. That's 2 rays, basically. So I can't, this is not an example here. It's got to be 2 lines that are crossing and they're dead straight lines. No, we're not changing the angle of either line. So basically it's 2 180-degree lines. Use the definition we just learned. Does anybody remember the name of those angles? What that is called? Those are certain types of angles when 2 lines cross. I'll go with Casey and then Elijah. If he gets it, I have another question for you.
Okay.
No, there's actually a word. There's a word. We're going to talk about the measures in a second. Well, the lines are intersecting, but intersecting lines form these types of angles. Elijah, did you want to guess? Not necessarily. One of them will be, one pair will be, one won't, but it's a little hard to tell, but this is not an acute angle here. This is an obtuse angle here. I could draw there. Now there's definitely one angle that's not acute. One's obtuse, 2 acute ones, 2 obtuse ones. Another word. Hangman. Well, I had to shorten up the letters. or the spaces. Three-letter. Louder.
A.
A. Next. So, I did I hear? Think somebody would get it. Although you don't know, the first letter is really the key. Man, no letter, no body parts yet at all.
N.
Oh, there's the first one. Did you want to guess? Oh, yeah, if you just guess, you don't need to write the answer. Yeah, good punch. Come on, come on. Why, how can you be so scared? There's nothing on the line. Guess. I wasn't scared. What was it? M, no M. T, did I hear? Somebody super quietly said T. Yeah. Vertical. If two lines cross, the angles across from each other are vertical angles. So this angle is vertical to this angle. It has nothing to do with just being up and down. It's the two that are across from each other. So these are vertical to each other. These are vertical to each other. Same thing here. These are vertical to each other. These are vertical to each other. Even though they're left and right, they're still called vertical angles. So the definition is something you do need to know, but here, because like when we get into proofs, you'll have to remember that that's one of your reasons why you can prove things is, well, I know if those are vertical angles, this particular thing is true. What is true about vertical angles? Super important. One of the most important things in geometry. Along with the next thing. When it comes to angle. Want to answer, I know. Oh, say it. What do you think? Yes. It's like you people are gonna get zeros or something if you guess. It's no grades or guessing. What? Yes. There. So it has to do with the angles being on the opposite sides, but what's true about those? What is true about this angle and that angle? They have the same measure. So if I took a protractor and if I measured, which we're supposed to do all kind of stuff with constructions and protractors and compasses, I don't know how they expect us to get through this stuff. It's the pacing guide is ridiculous. But if I took a protractor and I measured that angle, assuming I had absolutely perfect straight lines, and then I took a protractor and I measured that angle, they would have the exact same number of degrees, same measure. So that's your first major note. Vertical angles, which again means opposite angles when two lines cross, have the same measure in degrees. If you want to add in degrees, we always measure angles in degrees. So what that also means, because I said there's two sets of vertical angles formed, those two angles that I just put the two little tick marks on, if you remember we did that before on line segments, one tick mark tells me that these two have the same measure, and then these two tick marks are telling me that these two have the same measure. Now these are not equal to each other, this one and this one, and clearly it's more obvious down here, so. The ones that have two tick marks are equal to each other. The ones that only have one tick mark are equal to each other. So that's one of the biggest things for proofs, for solving out, like when we have missing angles and we have to solve for what the measure of the angle is. That's huge. They're going to come to that one all the time. And for some reason, that's one we forget a lot, or at least when I taught geometry before, that was one that kids forgot a lot. Here's the next one that is just as important and forgotten even more than that one. Is anybody still writing that? Vertical angles, opposite angles have the same measure. All right, here's the other one, and I don't know why this one is so. Oh, that's right. Yeah, we're on the book. Yeah. What's true about angle 1 and angle 2? Anybody can just get it right. 1 and angle 2. 2 answers really say they're true. Take a shot too. What do you think? Well, 1 would be obtuse, so obtuse means it's bigger than 90 degrees. So 2 is obtuse. 1 is acute. So if you don't remember obtuse and acute, obtuse means it's bigger than 90 degrees. Acute means it's smaller than 90 degrees. But more specific to those two angles and the relationship they have. Good. So I'm going to come back to it. First of all, they're not opposite each other, right? Like when we did vertical angle, now there is an opposite angle for 2, and that's 4. So we know 2 and 4 have the same measure. I can go ahead and write that because 2 and 4 are formed by this line FG and this line AC. So those are opposite. 1 and 3 have the same measure. They're formed by the same lines. Well, what is true about 2 and 1? So the word that I'll give you now, without you having to come up with it, they are adjacent. So they're next to each other. That's what adjacent means. But they are a special kind of adjacent. Adjacent angles are like 8 and 9 are adjacent. 9 and 10 are adjacent. 10 and 6, 6 and 7. That means the two angles next to each other. They share a side. So adjacent means they share a side. But there's something even bigger about 1 and 2. That, along with vertical angles, for whatever reason, kids forget all the time when we get down the road and we're either solving problems or doing proofs. So I'm going to repeat what Dylan just said. If I have a line, doesn't matter if it's a line segment or a line or whatever, I'm going to make it a line. How many degrees in that we said? 180, right? I showed you if I kept opening a ruler, or not a ruler, if I kept opening up my angle, eventually if I get to a straight line, that is a 180 degree angle. You could also think of it at, well, that's technically we don't know that. What's that mean? So that's a 90 degree angle. If I then say, okay, I've got this line here with two 90 degree angles, well, then that means the line on the bottom is 180 degrees. There's all kind of ways to show that a line is 180 degrees, but you just need to remember a straight line created by two rays that have opened up into a straight line is a 180 degree angle. So if this is 180 degrees, and I'm going to kind of mimic what we're seeing right here with FG, so I'll even name it FG. So we'll say that's FG. I then drew a line through that, and I'm only going to draw the ray. I'm just going to draw the ray from B to A. So B, I don't even know, it doesn't really matter where it is. So that's B. And then A out there. Did I change like the measure of FG? Did I do anything that affected FG? I mean, I divided it in half, but FG itself is still that one, or not in half, I shouldn't say, but I divided it into two angles now. But FG, the measure of FG, so that whole measure there is still the same. I didn't do anything. I didn't change the angle. I didn't close it or open it more or anything. I just put a line through it. So the measure of FG is still 180. It did not change that at all. Well, if I've now created two angles out of that, what does the measure of those two angles have to be if I add them together? Gotta still be 180, right? They make up that line now. Now I have two angles that make up, it's kind of like a line segment, same concept. If I start with one big line segment, and let's say that's 10, if I create two little line segments, well, if I add those two little line segments together, they still got to add up to 10 because that's the original line segment was 10. Here, the original angle is 180. If I split that into two smaller angles, they still have to add up to 180. It's the same concept. For some reason, once we move away from this and we're no longer like specifically doing that rule, kids forget all about it. It's called collinear angles, by the way. Collinear is kind of like points on the same line or collinear. Angles that make up the same line are collinear. So angle, you could say angle FBA is collinear with angle ABG. They make up that bottom line. One side of this angle and one side of this angle make up the bottom line of that figure. They're opposite rays going in opposite directions that form a 180-degree angle. All right. I want you to name. Oh, wait, this is hard to do. I already used some of them. Tell you what, I'll let you, I guess, use some of the ones we've already used. I want you to name, and this is probably something they have. Oh, yeah. Tell you what, go ahead and do that one. Just give me, you don't have to give me a whole bunch of them. Give me one more angle that has D as a vertex. So don't use these. So you see which ones. They should be in your pages, I think, right? Page 62. You have the same thing. So go ahead. If you can fill all three of them in real quickly, you better be able to get at least one. Go ahead and do that. You have it on your paper. I think they've got the figure and everything, right? Yeah. Yeah, so you should be able to do it from your paper. I'm probably going to regret this, but I'm going to skip over some of the stuff and get to some of the harder questions. I am going to point out the next one. Give me one answer. What's another one that has D as a vertex? It's not one that they already listed. CDF, I definitely don't see that listed. So now let me go to the figure. So if D is a vertex, C, D, and then out to F. Works for me. Did they have CD? They didn't even have CDB, so that looks like it's another one. Although technically that's the same angle. CDB and CDF are really the same angle. I don't know if that's okay for them, according to them, but I'm not super concerned about that just yet. If I'm talking about the numbers as angles, you do need to understand what all these numbers mean. Like 2 means it's this angle here. So if I talk about angle 2, I have to be able to find the sides of that angle. That can get a little confusing when you got that much stuff going on. I'm not going to spend a whole bunch of time on it. I think the more problems you see that we get through, the more that'll start to just automatically get absorbed. So we're going to go ahead and skip. They do a bunch of them where you just are naming the different sides of different angles. Let's go ahead and go into something. Well, actually, I didn't even get to this in the last class. Oh yeah, we're not going to do that. Well, we might do that. Tell you what, I will do that, and I can tell everybody that we recorded it. So here's one of the standards that you're supposed to learn that we're just frankly not going to spend a lot of time on. Why can I not zoom out? Or zoom? Oh, I guess that's his shoot. Kind of hard to do when you can't even see the whole thing on the screen. So what you have to be able to do, don't back up yet. There is a standard where you have to be able to, and they do have tools and they probably won't have it in the district test, but in your EOC for geometry, there are tools that you can actually use that are just like a protractor or like a compass. And you will have to be able to do this. They want you to be able to create this angle right here from this line by using a compass. So if you don't remember what a compass was, it's that thing that like has a really sharp point on one end, and it opens and it closes. I don't have this one out of the package, but it's like this thing right here. So you put a pencil in it on one end, and then the other end has a super sharp point, and you can draw a circle with it, or you can create angles with it. I have some other ones somewhere. And forever looking. If we're not going to use them, there's just no time to do everything they want you to do. So I'm going to show you the way you would do this. Again, if you don't get it, I can't imagine there's going to be tons and tons of stuff on it, but hopefully just by seeing it, you can kind of imagine it and maybe remember it, because some of it's just kind of sort of logic and common sense. So if I have this line and I want to create an angle that's the exact same measure as that angle, and all I have is, I don't have a protractor, I just have a compass. First step is I take my compass and I would put the pointy end, so I guess that's called the thumbtack. The pointy end would go on the B, the vertex, and I would open it up to some length, like in this case, they're opening it up to this length right here. So they're opening it up to where it's as big as point C. I wish I had a big gigantic. Oh, I can kind of use this. So let's say this is my compass. So this is my compass. One end is the pointy end. One end is the. Not really. So I put the pointy end here and I open it up to where it's that exact length to C. Right. So I leave it there. Now I'm drawing, so the pointy end stays there, and I'm like swiveling in it to make that line. So what I've done is I've just made a little arc that connects from this point to that point. All right. Again, if you're not getting this, you can't possibly cover everything. So this, by the way, is on the it's on the angle, the original angle. It's not on this line yet. We haven't done anything on that line. So I've just created from the angle that they gave me that. Now what I'm going to do is I'm going to do that same exact thing from the one that was just the ray. So I haven't moved it. It was at the same distance here, and I just do the same thing. I create the same exact arc. So I've duplicated this arc. Starts at the same distance. It's going to go up, and exactly if I took this and if I moved it on top of that, they would fit right on top of each other. They're a carbon copy so far. I just got to figure out a way to now get this line in the exact same spot that it's at right there. All right, so this is a carbon copy of this right here. I'm just missing that line. So now what I do is I take this again and I'm going to open it up, but now I'm going to open it up to the length from this point to that point. So I take it and I open it up again. I put the pointy end on C. I open it up to where my pencil touches A. So the pointy end is on C. My pencil is on A. And then from there, so I get that measure. From there, I come down and I now draw in on the line. So now this is the line where I had that arc drawn. I now draw in another arc going sideways. So this arc right here, I drew in going sideways. Again, that's gonna match up with point A. I can draw a straight line now through where those two arcs intersected, and it creates an exact copy of that other arc. That, I don't know how they would possibly do that on your district test, but they might have a way to do it. I don't know. I know they have a way to do it on the EOC. So if you didn't get it, again, maybe we'll show a video, but I doubt we'll ever get to it. There's no time to try to do all of the stuff they're trying to. I mean, we're so far behind. It's not even fun. So then you would have, once you drew that straight line, you would have a carbon copy of the other angle. All right, so next class, I'll give you the retake sheet that you're gonna have to get filled out. Again, that's gonna take a little time. There's not gonna be a super fast turnaround on that. We'll have a lesson and we'll do corrections next class also. I don't know on how many quizzes. And then you'll have the rest of the lesson on angles and then a quiz on Monday. So that'll get us all the way through. Make sure you bring your pages back. So the pages you just tore out, whatever, something through 90, I think it was 57 through 90 or something maybe.
Yeah.
57, 50 something through 90. So we probably will use those next week too. We're not going to get through all of those on Thursday. Probably not even close to all of them. Maybe it's been raining this time of day a lot lately. In the afternoon. You can do phones. Some of you are already doing phones. This class is relatively good about phones, though. Except for some people that were on. Did you guys quiz? That was missing?
Like on both, it says missing for both of them.
See you Thursday.
I'll go back. I mean, that would mean that you missed it, that you weren't here.
We were here.
I'll go back to them. For both of you?
Yeah.
All right, I'll look right now. Which one was it the same one for both of you? Same quiz, like same two
It
standards?
was something we all took, like, everybody took on that.
Oh, you mean the recent one we just took?
I think
The
it's,
weighted averages?
yeah,
I haven't even put that one in. Shouldn't say anything for that one. I'll go look.